Hey guys, in this video we're going to take a look at solving logarithmic functions. Now before we look at examples of solving them, let's recall one thing. So we already know how to convert a logarithmic form to an exponential form. So let's say we had log base A of C equals to B. What I can do is use a swoop and loop technique by reading it as A to the B power equals to C, which would be converted as an exponential form. So we have A to the B power equals to C. So we go from logarithmic to exponential form. All right, and I also want to introduce you to some kind of formula that I want you guys to be well aware of, which is a change of base formulas. Let's say we wanted to evaluate this log, where we have log of C of A. Now, if you guys notice in your calculators, there is no button where it will allow you to type it in like this. Log, we have log of a base, log base C of an output. Because of that, we use a formula so that way we're able to evaluate this in my calculator, which is this formula, where we have log of A divided by log of C. Now these logs are the common logs, since there is no base, and with a common log, the base is automatically 10. So we have log of A divided by log of C. So we're going to take a look at two examples where we use a change of base formulas. But for right now, what we're going to do is we're going to convert logarithmic form to exponential form to solve. So we have part A and part B. Now part A, we have log 3 of x equals to 4. So with these two, all we need to do is just convert it to exponential form, starting with A. So if we convert this to exponential form, it will be converted to 3 to the 4th power. If I use a swoop and loop, 3 to the 4th power equals to x. And then if I raise 3 to the 4th power in my calculator, so that means that I'm multiplying 3 4 times. 3 times 3 times 3 times 3. Okay? So we have 3 to the 4th power, and that gives me 81. So x equals to 81. All right, so we have x equals to 81 as my first answer. Now let's take a look at part B. Now part B, we have log base 3 of x minus 4 equals to, we're going to make this a positive 3. All right, so we have log base 3 of x minus 4 equals to 3. Now I'm going to change it to an exponential form where we have 3 to the 3rd power equals to x minus 4. So if I raise 3 to the 3rd power, I'm going to get 27. So I have 27 equals to x minus 4. And all I need to do is solve x by working my way backwards. So I want to isolate x by moving this minus 4. So what I need to do is I need to add both sides to 4, since that's the opposite of subtracting 4. So now x is going to equal to 31. All right, so x equals to 31. So that means that if I were to plug 31 into my equation, I would have 31 minus 4, which is 27. And log 3 of 27 equals to 3. All right. So let's take a look at other two set examples where we're still converting logs, but now we're going to be using common logs. Now, common logs is where we have no base, which makes it automatically 10. All right, so we have log of 3x equal to 2. Let's go ahead and convert this to an exponential form. So I have 10 to the 2nd power equals to 3x. Now, I'm going to do 10 to the 2nd power, which gives me 100. So if I divide both sides by 3, and x is going to give me 100 over 3. If I plug this in my calculator, I'm going to get a terminating decimal, which is 33.3333, or you can just round it as 33.3. 33.3. if you prefer. All right, let's take a look at part B. Part B is a similar technique. Now with letter B, I'm gonna convert it to exponential form. So this is my common log where there is no base, which makes it automatically 10. So I have 10 to the third. So remember, 10, this would be 10. Same thing over here, if there is no base. So we have 10 to the third equals to 3x minus 2. So if I raise 10 to the third, I'm gonna get 1,000 equals to 3x minus 2. So now I just need to solve. I add 2 to both sides, I get 1,002 equals to 3x. Divide both sides by 3. Then x equals to 1,002 over 3. All right, so this would be my final answer. Okay, so now we're gonna take a look at a third scenario where all we're just gonna be doing is we're gonna be using the change of base to evaluate these two logs, starting with A. Now, if we recall, when using the change of base, all we need to do is rewrite it as a quotient of two logs, where the first one we're using the output, and then the second one, the one in the denominator, would be the base. So the numerator is the output. The denominator is the base. So let's go ahead and do that, use that formula. So we have log 2 of 12 equals to x. So I'm going to use a change of base formula. So with the change of base, I have log of the output, which is 12, divided by log of the base, which is 2. Let's go ahead and plug this in my calculator. So if you don't have it, I want you guys to take out your calculators. So we have log, log of 12 divided by log of 2. So we're just going to round into 2 decimal places, and that gives me 3.58. So x equals to 3.58. So this would be my final answer for part A. Now part B is the same exact thing. Part B, we're going to use a change of base formula. So I have log of the output, which is 40, divided by log of the input, which is 3. So let's go ahead and evaluate this in my calculator. So I have log of 40 divided by log of 3, which gives me 3.36. So x equals to 3.36. So this would be my final answer for part B. All right. So we looked at scenarios where we're solving for logs. We're solving for a single log by converting, or just using the change of base. So we're going to take a look at a few more examples. But now, instead of solving with just one log, let's say we have a situation where we have 2 logs in an equation and we have to solve it. Now, before we take a look at examples, let's recall one thing. Now, if we recall one thing, we have the properties of logarithm. So we have 3 properties of logarithm, which is the product, the quotient, and the power. All right? So we have log of A. So we have the product, which is a sum of 2 logs. So what I have over here is the expanded version, because we're going to see a lot of problems where we have a sum of 2 logs, a difference of 2 logs, or we may have a number being multiplied by a log. If that's the case, our goal is to condense it into a single log. So let's say we're adding 2 logs. If we want to condense it, then what we can do is multiply the 2 outputs for the product property. Then for the quotient property, if there were 2 logs being subtracted, then I could just rewrite this as a log of a quotient, a divided by b. Now the power is where, let's say we have a number in front of log. The number is in front of line. Now, if we want to condense it, meaning clean it all up, the number in the front, has to go in back of the line, which is going to turn into a exponent. All right, so what we want to do is we want to go from this to this. We want to go from the expanded to the condensed version for any one of the properties. Now let's take a look at one more property, which is the equality property of logarithm. Now this one would definitely help us for some of the problems. This property states that if log C of A equals to log C of B. So if my bases are the same, then that means that I can get rid of the 2 logs and just have the 2 outputs equal to each other. So that means that A will have to equal to B. If the logs are the same, it can't just be log 2 of A equals to log 3 of B. The bases have to be the same exact thing in order to use the equality property. All right, so let's take a look at my first example where I can use the equality property to solve. Now with A, I have log 4x equals to log 5. Now, both of these are common logs where there's no number in the middle to indicate the base. So that means that the base is automatically going to be 10. So since the bases are the same, we can use the equality property. So we can make 4x equal to 5. And all I need to do is solve by dividing both sides by 4. Then x is going to equal to 5 over 4. Or if I were to write it in a decimal, it's going to be 1.25. All right. So let's take a look at part B. Now part B, we have log of x plus 4 equals to log of x plus log of 4. Now this one we have 3 logs, especially over here we have 2 logs. Now this is where we recall we want to use the properties of logarithms to further condense these two, clean it all up. So what property could I use to condense these 2 logs? If you guys said product property, then you're absolutely right. So what I can do is rewrite it as log of x times 4, which is 4x. All right, so I have log of x plus 4 equals 2 log of 4. And once again, the 2 logs are common logs, so that means that the bases are going to be 10. So I can use the equality property. So I have x plus 4 equals to 4x. So now I just need to solve. So I have x plus 4 equals to x. What I want to do is I want to set x on one side and leave the number on the other side. So we see that we have x plus 4 and equals to 4x. I want to isolate the 4 and by bringing this x to the same side as 4x. So to do that, I got to subtract both sides to x, which gives me 4 equals to 3x. Then I divide both sides by 3. Then I get x equals to 4 thirds. So then that would be my final answer. All right. So let's take a look at another example where we can't use the equality property, but we can use the other 3 properties of logarithms to solve for part A, part B, and part C. Now for part A, we have log of x minus log of 4 equals to 3. It's not possible to use the equality property. Even if I want to move log 4 to the other side, I still have this 3 in the way. So what I can do is I can condense these 2 equations by using the quotient property. So that means I'm going to rewrite it as log of x divided by 4 equals to 3. So now I just have a single log of x divided by 4 equals to 3. So what I can do is I can convert it into a exponential form. So this is a common log where the base would be 10. So I have 10 to the third power equals to x divided by 4. So if I were to raise 10 to the third, I get 1,000 equals to x over 4. And then what I need to do is get x by itself by doing the opposite of dividing by 4, which is multiplying. So I multiply both sides by 4, and x equals to 4,000. All right, so then this would be my final answer. X would equal to 4,000. All right, so let's take a look at part B, where we have 2 times log of x minus log 4 equals to 2. So this one we have two properties and we want to condense it. So we see that 2 is being multiplied to only this log, not both of these, just for this one. All right, 2 is only for the first one. So if you want to put parentheses in it to be in between those two to help you, it would be very helpful. So the first thing I want to do is I want to clean this one up since we have a number in the front. Now I can use the power property to move this 2 behind the line. So I'm going to bring it behind this x and turn it into an exponent. So it's going to be log x to the second minus log 4 equals to 2. So now I just have a difference of 2 logs. And with that, I can rewrite it as log of x squared divided by 4 equals to 2. All right. So now I just have a single log of x squared minus 4 equals to 2. That's what we want. We want to just have a single log so that way we'll be able to convert it into an exponential form. So yet again, this is a common log. We would have 10 to the second power equals to x squared over 4. So if I convert it to x squared over 4, if I evaluate 10 to the second, I'm going to get 100 equals to x squared divided by 4. Now I want to try to get x by itself. Now what I do is I have to do the opposite of dividing by 4, which is multiplying. So I multiply both sides by 4. Bring this in the way. I have 400 equals to x squared. All right. So now I'm going to take the square root of both sides. And let's think like a calculator. We're only going to use the positive version, not the negative. So I have x to the second power. If I square root that, I just get an x. So that means that the square root of 400 is going to be 20. So my final answer is going to be 20. All right. So all we did was we used the quotient power property first to make it an exponent. Then use the quotient property to rewrite it as a division. Then we convert it into a exponential form. And then right after that, all we just had to do was solve for x, which you guys are pretty familiar with solving. Let's take a look at part C. Now part C, we have a log on one side and a log on another side. And unfortunately, the equality property won't be applicable for this one because we see we have a -1 in the way. So what we want to do is we want to try to bring every log to one side and leave the -1 by itself. So what I can do is I can move log 2x to the other side. Now if I'm moving it to the other side, then the sign is going to change from a positive to a minus. So I can subtract both sides by log. I'm going to get log of 8 minus log of 2x equals to -1. All right. So what I'm going to do now is I'm going to use one of the properties to condense the difference, which is going to be log of 8 over 2x equals to -1. So now that I have a single log, I can go ahead and convert it into an exponential form. So I have 10 to the negative first equals to 8 over 2x. Now, if you guys recall, if we have a negative exponent, we want to change it to a positive by flipping it, by bringing it to the denominator. So this will turn into 1 over 10 to the first, which is just going to be 10, equals to 8 over 2x. All right? So 10 to the first is automatically going to be 10. So now I have two rational expressions equaling to each other. So in this situation, what I can do is I could cross multiply. So I cross multiply. 1 times 2x is 2x. And 10 times 8 is 80. So now all I need to do is divide both sides by 2. And x equals to 40. So my final answer is going to be a 40. All right, so we're going to amp up the level a bit by doing one more problem. So for this one, we have log base 3 of x minus 5 plus log base 3 of x plus 3 equals to 2. Now, the first thing we can do is use the properties of logarithms to further condense these two logs right here. So what we can do is, since we have these two logs adding to each other, I can rewrite it as a single log. So we have log base 3 of x minus 5 times x plus 3 equals to 2. Now I'm not going to FOIL this yet, just because now we have a single log of 3 times log 3 of x minus 5 times x plus 3 equals to 2. Now what I can do is, since we already have a single log, we have a base, which is not a 10, which is now a 3, and then we have the output equals to the exponent, we can go ahead and convert it to exponential form. So I'm going to do the scoop and loop technique where I read it as 3 to the second. So I have 3 to the second equals 2. X minus 5 times x plus 3. All right? So I can go ahead and evaluate both sides. So 3 to the second power is 9. And if I were to do the FOIL method, x times x is x squared. X times 3 is 3x. Negative 5 times x is minus 5x. And negative 5 times 3 is negative 15. All right, combined like terms, we have 9 equals 2x squared minus 2x minus 15. And now it looks like I'm almost going to have a quadratic function. So what I can do is move 9 to the same side as everything else by subtracting both sides by 9. We get 0 equals 2 x squared minus 2x minus 24. So now we have a quadratic function. All right. So we have a quadratic function after we converted the logarithmic form to exponential form. So all we need to do is we're still solving for x now. But now, instead of just having a single answer, now we're going to have two answers. All right. Now, what we can do is we have a regular quadratic equation where we could factor as two binomials. Remember, when we factor a quadratic function, we find two numbers that multiply to the last number and has to add up to the middle number, which in this case is -6 and +4. And then by using the zero product property, if I make each of these equal to 0, I get x equals to 6 and x equals to -4. So I have two solutions for this one, but only one actually works and the other one doesn't, which makes it a extraneous solution. So I'm going to see which one works by plugging one of these numbers. 6 and negative 4 into my function, into the original function, just for double checking. All right, so just to double check, all right, so I'm going to double check on this side. So I'm going to plug in 6 into the equation, all right, into the original function. So we have log 3 of 6 minus 5, which is 1, plus log 3 of 6 plus 3, which is 9. So log 3 of 9 equals to 2. Now, if I were to evaluate each of the following, log 3 of 1, now 3 to what power gives me 1? 3 to the 0 power. So if I make, so this would be 0 plus, and then I have log base 3 of 9. 3 to what power gives me 9? 2. So log 3 of 9 is 2. That gives me 2. So 0 plus 2 equals to 2. That works. So 6 definitely works. But now we have negative 4. So if I plug in negative 4 into the equation, I have log 3 of negative 4 minus 5, which gives me negative 9. Now right away, I get a negative number, which cannot happen. All right, I can't have a negative number when I'm evaluating log. So in that case, the negative 4 is going to be my extraneous solution. And only 6 is my actual solution for this one. All right. So we took a look at all the problems where we were solving logarithmic functions, whether we had 1 log or 2 logs. All right. You guys could always rewatch parts of the video, rewind, fast forward. All right. So if you guys still have any other questions, feel free to email me. I hope you guys have a wonderful day.